Man, J. Alice, I'm really about to fail this chemistry test. What even is a chemical reaction?
Well, my notes here say a chemical reaction is the process by which one or more elements are rearranged to form different substances.
It's like, does it change color? What does it do?
It can change color, it can release gas, it can bubble up, or it can excrete heat. A whole bunch of different things.
What? But J. Alice, how do we know what's happening in a chemical reaction?
Well, there's things called chemical equations that will help us to figure out what the products may be and how they may react.
Let's take it onto the lab so we can look at these chemical equations. So J. Alice, what do you mean there's different types of reactions?
Well, there's 6 different ones, including synthesis, decomposition, single replacement, double replacement, combustion, and neutralization.
Oh, I think I remember.
So, one of the first types of reactions is synthesis. The formula for synthesis is A plus B yields AB. So you're basically just combining them. An example is 2 NaCl plus Cl2 yields 2 NaCl. And I have these 2's underlined here because I balanced out my chemical equation. You have to make sure your equation is perfectly balanced. Another type of reaction is decomposition. This is basically just the opposite of synthesis. So the formula is AB yields A plus B. See how they're related? Yeah, you get it. So an example is the opposite equation, 2 NaCl yields 2 Na plus Cl2.
So we also have single replacement, and the formula for this is A plus Bx yields Ax plus B. And an example of this is Fe plus CuSO4 yields FeSO4 plus Cu. And for this equation to work, anions switch with anions and cations switch with cations. And in this case, we have 2 cations that switch, which is copper and iron. Now we also have a double replacement, which is Ax plus By yields Ay plus Bx. An example is NaCl plus AgNO3 yields NaNO3 plus AgCl. And this equation is also already balanced, and for this we have 2 cations switching, and then we have 2 anions switching.
Okay, so another type of reaction is a combustion reaction. An example for this is CH plus O2 yields CO2 plus H2O. We know this is a combustion reaction because oxygen gas is present. And combustion reactions always yield carbon dioxide and water, CO2 and H2O.
Finally, we have neutralization, which is an acid plus a base yields water and a salt every single time. And an example is NaOH, which is the base because it has the presence of hydroxide, plus HCl, which is the acid because it has the presence of a hydrogen atom, yields H2O and NaCl, which is water and a salt.
Once the products are found and the equations are completely balanced, we can use stoichiometry to find limiting and access reactants. Stoichiometry is a way we use math to convert one measurement into another. Let's take it to J now so we can show y'all an example.
The example we're going to use for the stoichiometry equation is going to be a neutralization. So the question is, how many moles of NaOH are in 200 grams of NaOH? Now, it gives us 200 grams of NaOH right here, and this is what we're going to need to start with. So now we're going to start writing down the equation. So first, it's given us 200 grams, and it wants us to convert grams to moles. So first, you're going to put 200 grams of NaOH, and then put a line going under it, and leave a little bit on the side, and then put one line. And now, since it's asking us for moles, we will put 1 mole of NaOH at the top. But now we still have grams, so we have to cancel it. And so we're going to put grams of NaOH at the bottom, so we will be able to cancel out the grams and we will be left with moles. But now we got to figure out how many grams of NaOH are in 1 mole. For this, we will be finding molar mass using the periodic table. The molar mass of NaOH is 40 grams. Now we will multiply straight across from the top and the bottom and divide out the equation. We have 200 times 1 over 40. And then, which is going to equal out to 5 moles.
Using basic stoichiometry problems like this, we can further develop them into finding our limiting and excess reactants of the equation.
You can also use stoichiometry to go from grams to grams. And so we use the same problem as we did finding grams to moles, but now we're going to go to grams. So from here, after you find the moles, you're going to cancel out the moles of NaOH using the balanced equation. So on the bottom, you would use 1 mole because there's an understood 1 in front of the NaOH. So you put 1 mole of NaOH on the bottom, and then on top you put the however many moles you have of HCl, which in this case is also 1. Now we're at moles of HCl, but now we're trying to get to grams. So we have to cancel out moles of HCl, so we're going to put 1 mole of HCl, because this is coming from the periodic table, and we just find the molar mass of HCl. And the molar mass is 36.46 grams of HCl. And now moles of HCl can cancel out, and you're left with grams. And then lastly, you have to multiply straight across from the top and the bottom. So we have 200 times 36.46 over 40 grams. And then 200 times 36.46 equals 7,292 divided by 40, which equals 182.3 grams of HCl. Using grams to grams stoichiometry will help us find the limiting and excess reactants.
Okay, Jane Alice, so chemical reactions and equations aren't that bad.
They're really not. They're
we might
very
pass.
simple. I mean,
okay, so as a refresher, just so I get it right, today we learned that chemical reactions and how you use balanced chemical equations can determine what type of reaction it is.
we also learned about stoichiometry, which also helps us take one measurement and convert it into another, which will help us get the amount of something that we might need.
For the balanced chemical equation, bro, that's crazy.
Yeah, I think we might pass.
So, me and Jane Alice, we're kind of killing it.
I mean, we learned a lot, and I think we may pass now.
Hope we helped y'all too. Y'all do good on your exam.
See you next time.
Peace.